I'd like to show you what I've been doing to create a LISP to Verilog translator. This program makes a generic Verilog State Machine, and I'll just go through the process from ground zero of showing you how it works. I'm starting up the LISP environment in Emacs right now, and the first thing I'm going to do is I'm going to switch to a temporary directory. We're going to go into, let's say, :/tmp/. Okay, and in here, well, anywhere actually, quick Lisp, quick load Lisp to Verilog. And now go to that package. Okay, once we've got this system L2V loaded, it gives us a new set of functions in Lisp. And over here, I will create a test file. We'll call it anything. Let's call it demo.lisp. And in this demo.lisp file, we write Lisp code using a thing called define Verilog State Machine, like this. We say def Verilog State Machine, and it wants a name. Let's call it demo, and it wants to know what the inputs, outputs, and parameters are. No inputs, one output, and the parameters are none for now. And now let's start writing. And in a def Verilog State Machine form, we can do things like this. Z is assigned to add to Z1. Simple as that. On the left-hand side, we can see a variable, and we see the non-blocking assignment, and then some Lisp code again. The right-hand sides are Lisp code. The convenience features are I've just arranged for it to read those kind of statements. We're going to compile that. It's now compiled, and now we're just going to run that. Run Verilog State Machine. And that wants to know, optionally, what is the Verilog State Machine you want to run, and it is demo. And I run that machine now, and that's what it does. By default, it will run at 100 megahertz, and it will run for 2000 steps. All those things can be changed in this run VSM macro, but just for simplicity, there we go. Now, let's turn this into Verilog. Make Verilog, try that again, make Verilog file, do it, and once we've made the Verilog file, we can run the Verilog State Machine called demo with the type Icarus. I'm supporting Icarus at the moment. So this will run it again now in Verilog. Here we go. And there it is. It's the same. Now, how did it do that? Well, it created a file called demo.v. This is that file. Demo.v is a Verilog State Machine description using the clock enable reset methodology. And you can see it's put some comments around it and indented it and made it look pretty. It also created demo.verilog test bench. And again, with some nice comments around it and made it look pretty. And you can see that it's done two things. It's written the LXT file, so you can use GTK wave if you wish. And it's also opened a temporary data file to record so that the GNU plot can plot. And all that was done automatically. That is just a simple case. Let me go back to that file there and say Z is assigned to Z plus 1. Let's do it a little bit differently. Let's say if equal Z 1000, then go to, let's say, minus 1000. Otherwise, let's just add to Z1. So you can see I've sophisticated it a little bit now. The right-hand side is Lisp again. Compile, run, and now we see that when the number gets to 1000, it goes to minus 1000 as we'd expect. Make the Verilog file again and run it again in Icarus, and there it is. Now let's go back to that file. There it is, that was last time. Alt-X revert buffer. And now look, the code has changed. And you can see that it figures out how many bits you need in Z and everything. You don't need to worry about that. It does it by tracking what's going on in the Lisp file. So this is a quick way for us to generate very quickly state machines in Verilog from just writing simple things in Lisp. It can do a great deal more than I just showed. That's just an introduction. Perhaps I'll show quadrature oscillator in the next demo. Okay, thank you.